Okay, someone asked about how do you tell from a Venn diagram that two things are independent? Does it mean that the events are separate like this? So here's our Venn diagram, here's a sample space. And here we've got A, here we've got B, and you see they don't overlap at all. In this case, they are what we call disjoint, because if you think about it, the area of overlap, or the probability of A and B, is 0. So what this means is that they're disjoint, they can't happen at the same time. In this case, they actually become very dependent, because, for example, if we look over here and we see the probability of A given B is the probability of A and B over the probability of B. We did this in the lectures. If the probability of A and B is 0, and in this case they're disjoint, so it's 0, it now means the probability of A given B must be equal to 0. So it makes sense they become very dependent, because if B's happen, and we know by being disjoint they both can't happen at the same time, A can't happen. So as soon as I know that B's happened, A can't happen. So disjoint means that they're very dependent. What does it mean when they're independent? Well, basically, they're independent if the probability of A given B equals the probability of A. What do you mean by that? Well, if we move these so now they have some overlap, so they're not disjoint, what it have to mean is that the probability of A, so this area here, is equal to the ratio of this area here, the probability of A and B, over the probability of B. So if the ratio of this area divided by this area equals this area, then they will be independent. So you can see it's not an obvious thing to see from a Venn diagram. Hope that helps. Bye.